Hello students, good evening. Welcome to another class by Vedantu, Karnataka. This is Catherine, your physics master teacher. Hello. Sorry, there was a small technical error. Yeah. Hello students, good evening. Welcome. Yes. So how are you all? How are your preparations going? And quickly let me know in the chat when your exam is. When is your FA1? When is your first unit test? Did you all get the timetable? Hello Amu. Hello RXBTCC. How are you all doing? All of you doing well? So are you all ready to learn motion in a plane in one shot? Yes? No? So we're going to finish motion in a plane, everything important, in less than 2 hours. Okay? Not less than, but maybe 2 hours. Are you all ready? Are you all ready for a power-packed class? Cricket League. Hi, Cricket League. Welcome to the lesson. Yes. No? Not ready? Cricket League is not ready? Baby, hello. Harshit. Rekha, hello Rekha. Welcome to the lesson. Hi. And it's good to see all of you in class. Did you all have your dinner? Are you all with full Josh ready for the class? Yes? If you're in full Josh, put fire emojis in the chat. Let's start the class with full Josh. Okay? I'm in full Josh. You should also be in full Josh. All of you go grab your pen, your book, whatever you want, and let's study motion in a plane. So students, motion in a plane is a chapter that's very important. Okay? Because in this chapter, you will be learning about vectors, which you need in your second PUC also. Okay? So one chapter in first PUC that you cannot ignore is this chapter. Okay? So please pay attention. Make sure you understand all the concepts. And since it's a live class, you can ask me doubts then and there, which is like a very good advantage. So what if you don't understand anything in class, you can just type in the live chat. I will explain it to you. Okay? Are you all ready? So this is a chapter that you need for your second PUC also. It's a very important chapter in your KCET, Comet K exams as well. Okay? So are you all with me? Full Josh. Let's start? Okay. So let's start the chapter. First, I'll tell you how we're going to start it. So this is going to be a one-shot class. I'll explain all the concepts to you quickly. Not quickly. I'll make sure it's all very clear to you as well. Okay? Okay, Prema has given me a thumbs up. Rekha has put some fire emojis. Cricket League is ready. What about the others? There are 14 people watching. Others? Quickly. Let me know that you're there in class. No? Type in the live chat. Let's have a mutual, like a class where you talk, I talk, and we have a class like that. Yes, Rekha, this is KCET topic also. So this lesson, I'm going to cover every topic. You can use it for first unit test, FA1, KCET, Comet K, your final board exams, anything. Okay? Okay. So let's start. First of all, in this chapter, what all are we going to learn? We are going to learn all of these things. First thing we'll learn is vectors, which is very important. So vectors is something that you will, if you're someone who wants to pursue physics as your future, just like me, okay? You will need to learn vectors because that is something you'll use everywhere, okay? And then we will learn about how particles or how objects move in 2 dimensions. So in motion in a straight line, I've already taught you how objects move in single dimension, like, when you're walking straight or, along one axis. In this chapter, we will learn how objects move in 2 axes, like when you throw a javelin. Okay. So examples for motion in 2D are projectile motion and uniform circular motion. So these are the 4 main topics that we are going to cover today. Yes? Are we on the same page? Agreed? Okay? Rekha, if we saw this video and understand the concept, means we can easily do the problem of CET. Yes, Rekha. If you understand the concept, then you can easily do it. Okay, you can trust me with this. I have taught KCT students, and sometimes they will come up in the chat and say, "Ma'am, I cleared KCT because of you," and all. You can see those. Okay, you can trust me, Rekha. Okay, let's move on. So let's start by physical quantities. So you might have already learned physical quantities in chapter 1. You have learned physical quantities. Yes, quantities with dimensions, all that you have learned. So in this chapter, in physical quantities, we will classify physical quantities as scalar quantities and vector quantities. Okay, scalar quantities and vector quantities. Now, what are scalar quantities? Scalar quantities are quantities that have magnitude only. Okay. Now, what is the meaning of the word magnitude? It means that it has a value. Okay. For example, I will say my weight is 50 kg. So that is the value of my weight, or that is the magnitude of my weight. So obviously, one example of a scalar quantity is mass. Okay. Mass. Then another example of a scalar quantity is temperature. See, I will say my body temperature is 28 degrees Celsius. I will only say the value. I will not say my temperature is 28 degrees Celsius in the north direction, or in the south direction, or in the west direction. No, I will say that my temperature is 28 degrees Celsius. Only the value is important. So such quantities are called scalar quantities. Yes, Manju, very good. Only magnitude. Superb, Manju. Now, vectors, on the other hand, are physical quantities that have magnitude plus direction. Okay, which means if you want to talk about a vector quantity, you have to look at what its value is and in which direction it is moving. So example will be velocity. Okay, will be velocity. So what is velocity? So velocity is basically speed with the direction. So when I am saying that boy was moving with a velocity of 5 meters per second in the forward direction. Okay, so whenever you talk about velocity, you have to look at the value 5. In which direction? Forward direction. So these two together becomes a vector. Another example I can give you is force. So if I'm pushing you, you are moving in the direction in which I'm pushing you. So the direction and the amount of force, both are important. Okay. So vector quantities are quantities where you look at the value of the quantity and the direction in which it is traveling. Okay. So these are the two types of physical quantities, scalars and vectors. Very important. I hope it is thorough to all of you. If it's thorough to all of you, put some fire emojis in the chat. Quickly, quickly. Let's burn the live chat. Put some fire emojis. Yes, Manju, very good. Manju is giving me all the answers. August, give me some answers. I mean, you might be thinking, ma'am, what question did you ask? Simply, you can write whatever you feel like. Like, if you know examples of scalars or vectors, type it out in the chat. Let's have an interactive session. Okay. Now, I'll ask you a question. Is electric current a scalar quantity or a vector quantity? The question is electric current a scalar quantity or a vector quantity? Tell me in the chat. It's Niru. Hi, ma'am. Hi, Niru. Hello. Welcome to the lesson. See, all of you there in class, please do me a favor. No, send this link to everybody in your class. Okay, in your class groups. Forward it to your class group. Tell them a very good class is happening. In one shot, you will learn the whole chapter. Come join. Okay, can you do that much for me? And please go like the video. I want to see all your attendance. Quickly go like the video. Yes, Prema, very good. Force, displacement are vector quantities. Okay. Rekha and Manju has said that electric current is a scalar quantity. Let us see what quantity is electric current. So let's look at that. Obviously, your answer is correct. Electric current is a scalar quantity. But why is it not a vector quantity? Why is it not a vector quantity? Very good, Tanushree. It's a scalar. Very good. Yes, Manju is very smart. It is not a vector quantity because it does not obey the rules of vector addition or vector subtraction or whatever. So let's look at some examples. So let's say there's a current of 5 ampere coming to a junction. Okay. Let's make it, okay. Let's say there is a current of 3 amps coming. From the sum also 3 amps are coming and they are at an angle of 60 degree. What is the total current output? 3 amps plus 3 amps is 6 amps. Now let's say now these two wires are kept at another angle 150. So again 3 amps, 3 amps. The output is still 6 amps. Now even if they are at an angle 180, okay. So 3 amps comes, 3 amps comes, you still get 6 amps, isn't it? So that means, the direction in which the wires are placed does not matter. It is always 6 amps. So here, the direction is not important. Okay? Is that clear? Yes? So this is the reason why current is not a vector quantity, and also as Manju said, it does not obey laws of vector addition. Yes? Are we good to go? Now, do you have a clear idea on scalars and vectors? Yes? Yes, Prema, it is a scalar quantity. Okay? Now, let's move on to the representation of vectors. So, students, from this part, it's very important. Okay? So, we are going to cover the basics of vectors. So, this basics, you should be very strong. Okay? So, whatever vectors you get, you should be able to solve after this class. Okay? Okay. So, first thing that we are going to learn in this class is representation of vectors. Okay? So, how will we represent a vector? So, let's say we represent a vector graphically as an arrow. Okay? It's going to be represented as an arrow with a tail and a head. Okay? Every arrow has a tail and a head. Okay? And the length of the arrow gives you the magnitude. Okay? So, the starting point of the vector is what? The tail. So, this is the starting point of the vector and the head is the ending point of the vector. Like this. This is the starting point of the vector. This is the ending point of the vector. And the length of the vector gives you the value, which is the magnitude. Is this clear to all of you? Yes? Starting point, ending point, tail, head. The length of the vector gives you magnitude. Now, for those of you who didn't understand this, I'll give you an example. So, imagine there are two vectors, okay? Let's say this is the first vector, this is the second vector. The first vector, let's say it has a value of 3. The second vector has a value of 5. You can see the fifth of 5 one is longer because the length represents the magnitude. Okay? Now, if there is another vector 1, it will be smaller. Okay? So, the length of the vector represents the magnitude and the arrow points towards the direction. Okay? Yes? Okay? So, if there are two vectors, these are two vectors in opposite directions. Okay? Yes. Yes, Rekha, it's 8. Very good. Rekha was adding the two vectors. Okay, so this is how you represent a vector graphically using an arrow. Okay, now let's see how you represent a vector algebraically. So this is what we're mainly going to use. So graphically, you will use it but not everywhere. But algebraic representation of vector is something you will use everywhere. Okay, so any vector, let's just say A. Okay, there is a vector A. How will I represent it? I'll put A and an arrow on top of it. Okay, how do I represent a vector A? A and an arrow on top of it. Okay, now what does this mean? Okay, so let's say A has a value of 5 in the x direction. What does that mean? So if this is the direction, it has a value of 5 and it's along the x-axis. You know x-axis, no? If you have a graph, it's along this axis and it's having a value of 5. Okay, so A is a quantity that is moving along the x-axis with a direction of 5. How will I represent that as a vector? I will show you. So what you will do is you will write it as 5, which is a value, and x cap, which is the direction. Okay? Okay? Is that clear? Yes, yes, yes. Mm-hmm. So 5 is the value of the vector, x cap is the direction of the vector. Now this can also be written as the magnitude can be A, direction will be A cap. Okay, so let's say if you have a vector P, P basically has a value of P and direction P cap. Okay, so the cap represents direction. Now if you have a Q vector, so as I said, the arrow represents vector. Q vector will be equal to Q and Q cap. So Q is the magnitude, Q cap is the direction. Yes, it's Nehru. Starting point is the tail, ending point is the head. Okay. Yes, A is the magnitude. Very good, very good. Superb, superb. Is this clear? Yeah. So, vectors are always denoted by symbols with an arrow on top. Okay. So, A, arrow, B, arrow, C, arrow are all vectors. A, B, C and all that. Is that clear? Okay. Now, let's put some numbers here. So P will be, let's say P is, let's say P is a quantity which has a value of 10 and it's moving along the Z axis. So this will be 10 Z cap. Okay. Now let's say Q is something, let's say Q has a value of minus 5 and it's moving along the Y axis. So Y cap. Okay. So cap represents the direction, the number represents the magnitude. Okay. Now, magnitude can also be represented as, for example, magnitude of P can be represented as P vector, but I put these two signs. Understood? See, simply P vector, what is it? Simply P vector. P and an arrow is basically P cap. Isn't it? See, simply P vector is what? P cap. Okay. But if I write P this one, that means P. Too confusing? So the magnitude P can also be written as P vector in mode. Okay. So now this I can modify. What will I write? P vector is equal to magnitude times P cap. Okay. I can write this. Now Q vector is equal to Q magnitude times Q cap. So these are all different forms in which you can represent a vector. Okay. So you can represent a vector like this. The magnitude can be represented by the alphabet alone and the alphabet cap represents the direction. This can also be written as the vector in mode. This also represents magnitude. Again, P cap is direction. So this and this, both these represent magnitude. Is this clear to all of you? See, can I have some confirmation? Can you all put some fire emojis in the chat if this is clear? Because I can't see your faces. This is very important, okay? You need to know this part because you will need them for a lot of derivations. So here, P cap is the direction. P cap is the direction. P and P. Okay? Students, quickly, can you put some fire emojis if this is clear to you? I want to know if this is clear to you so I can move on to the next topic. Okay? Yes, no. Oh, my phone is falling down. Yes, no. No response. Quickly, some response. Is this clear to all of you? Bharati, it's Niru, Rekha, Manju, Harshita, Prema, Tanushri. Quickly, let me know if this is clear to you. Where are all my lovely smart students? Yes, ma'am. Okay, Rekha's put fire. Okay. So I believe it's clear to all of you. Okay. Okay. Now, imagine there are two vectors and they have an angle between them. Okay. So let the first vector be A cap. So A cap, A vector, A and an arrow is how you represent a vector. Okay. B and an arrow is how you represent another vector. Graphically, this is how you represent a vector, a line with an arrow. Okay. So these are two vectors, do you agree? Graphically and algebraically, these are two vectors, A and B. Okay. And let's say they are at an angle theta. Okay. Now I can have two vectors. So this is vector B. This is vector A. Now the angle between them is 90 degrees. Okay. Now I can have two vectors. This could be vector A. This could be vector B. What is the angle between them? They're parallel. So angle would be 0 degrees. Now imagine you have this as vector A and then this as vector B. Now what is the angle between them? 180 degree. Okay. So these are all different angles that vectors can form. Vectors are just any two vectors. So however they're placed, they will always have they can have some angle between them. Okay. Now depending on the angle between the vectors, you can call them as different angles. Okay. Sorry, you can call them as different vectors. Okay. So they all have some names which are also important. Let's learn those names. Ready? Ready for learning those names? Okay, so that comes under types of vectors. So first one is perpendicular vectors or orthogonal vectors. Okay, so what are orthogonal vectors? Orthogonal vectors are when you have two vectors. Okay, let's say this is A and this is B and they have an angle of 90 degree between them. Okay, so orthogonal vectors are basically perpendicular vectors. So if two vectors have an angle of 90 degree between them, then they're called orthogonal vectors. So imagine in questions for your exam, they will just tell you two vectors A and B are orthogonal. Find out the angle. I mean, not that straightforward, but you should know. If the word orthogonal is there, it means the two vectors are perpendicular to each other and the angle between them is 90 degree. Okay? You all agree? Okay. Now, next. Hi Sanket. Hello, welcome to the class. Okay. Next is parallel vectors. Okay. So what are parallel vectors? Obviously, just like the name, it's when two vectors are parallel to each other. So, okay, so if this is one vector, this is the second vector, and they're parallel to each other. So obviously the angle between them will be 0 degree. So those kinds of vectors are called parallel vectors. Okay. What is the next kind of vector? It's called negative vectors. What are negative vectors? Negative vectors are when you have two vectors that are equal in magnitude but opposite in direction. Okay. So how will you represent magnitude using an arrow? So if you say equal in magnitude, you should put the same size arrows. But opposite in direction means it should be represented like this. Okay. Same length but in the arrow head should be pointing towards two different directions. Okay. So length of the arrow is what represents magnitude, and where the head points, what is head? The tip of the arrow. The head points towards the direction. So what I have drawn here, these are two vectors equal in magnitude but opposite in direction. Okay. So such vectors are called negative vectors. Okay. So this is minus A. Next is equal vectors. What are equal vectors? They also have same magnitude, same direction. So they are like parallel vectors. But here the difference is same magnitude and same direction. In parallel vectors, they need not have same magnitude. They just have to be parallel to each other. Okay. Equal vectors are vectors that have same magnitude, which means same length and pointing in the same direction. Okay. Last one is null vector or zero vector. What is a null vector or zero vector? Obviously, it has a value of 0. But how will a vector have a value of 0? So imagine this is a point and there are vectors acting in upward, downward, left and right direction. So what happens? They will all cancel out and the net vector will be 0. Okay. So if you have, as I said, if you have a vector A and a vector B, if they are equal in magnitude and opposite in direction, they will just cancel each other. Same thing if you have a vector up, another vector down, they're equal in magnitude and opposite in direction, they will again cancel. So the net vector will be 0. Okay. So a 0 vector or a null vector is a vector which has 0 magnitude, which means no value. Okay. The value is going to be 0. Is this clear all of you? What are the different kinds of vectors? Orthogonal if the angle between them is 90. Parallel if the angle between them is 0. Negative if they have the same value but they have different directions. Equal if they have the same value, same direction. 0 if they have a value of 0. Okay. Can I have some response, students? I am here blabbering and you have to put at least some emojis in the chat. Okay. Quickly put some fire emojis in the chat if this is clear to all of you. Hi Akshay, welcome to the lesson. Yes. Okay. So, see, imagine I am sitting in a room looking at a screen and teaching. So, what is my motivation when you give answers, when you talk in the chat, when you put these fire emojis and all of that? So, please do that. Yeah. Let's have an interactive session. I am your teacher and you all are my dear students, no? Yes. Okay. Okay. So, is this clear to all of you? Any doubts in types of vectors? Okay. Super. How many of you had your dinner? All those who had dinner put fire emojis in the chat. Okay. Next is unit vector. Okay. So, what is unit vector? Now, imagine there are 3 axes. Okay. 3 axes. X-axis, Y-axis and Z-axis. Okay. X-axis, Y-axis and Z-axis. Along X-axis, it's X cap. Okay. Along X-axis, we call it X cap. So, if a vector is moving along X-axis, we call the direction as X cap. We can also call it as I cap. Okay. Along Y-axis, if a vector moves along the y-axis, you can say it's moving along the y cap or you can say it's moving along the j cap. Okay. If it's moving along the z-axis, you can say it's moving along z cap or k cap. Okay. So from now on, students, x-axis, y-axis, z-axis can also be called as I cap, j cap and k cap. You have to by heart that. Okay, that is a sign convention you will be using throughout. So instead of x cap, I can say the vector is moving along the I cap. Okay, so if you are running along this direction, along the x-axis, I can say you are running along I cap direction. Okay? Okay? Yeah. Now, what is a unit vector? That is what we are going to discuss here. So what is a unit vector? So let's first represent a vector. So there's a vector A. Okay. There's a vector A. How do you represent a vector A? By looking at its magnitude. How will you represent magnitude of A? A between the lines. How will you represent direction of A? A cap. This is how you generally represent vectors. We've already learned this. Now, if I rearrange this and write A cap is equal to A vector by magnitude of A vector. Okay. What is this? This is the same as A vector divided by A. This I've already taught you. Yes? Yes? Is this clear? See, magnitude of A can be either written as A vector inside lines or simply A. So this is basically called as unit vector. Okay. So this is actually called as unit vector. So what is unit vector? It is when a vector is divided by its own magnitude. For example, a vector A is divided by the magnitude of A. That is called as a unit magnitude or a unit vector. Okay? Okay, Netra. Netra says it's clear to her. Okay? So, what is a unit vector? A unit vector is basically a vector which has a cap, like A cap, B cap, C cap. And what is it? It is equal to a vector divided by the magnitude of a vector. Now, let's write down another example of a unit vector. So, let's say P. P cap is a unit vector, so it will be the vector P divided by the magnitude of P. This can also be written as the vector P divided by, again, magnitude of P. These are two ways in which you can represent magnitude of P. Okay? Is unit vector clear to all of you? Yes, no. Okay? Now let's write down an example. So let's say if A is equal to 10x cap, it also means 10I cap. Isn't it? Now let's take a vector B which is equal to 5y cap or 5j cap. Okay? Now, if I have to find C, which is A plus B, A vector plus B vector, this will be nothing else but 10I cap plus 5j cap. That's all. Okay? 10I cap plus 5j cap. Okay? Is this clear to all of you? So what is a unit vector? A unit vector A cap is basically the vector. What is the vector? Whatever alphabet with an arrow on top divided by the magnitude, which is that alphabet alone or that alphabet with an arrow on top and two lines. Is this clear to all of you? Yes, no. Where are the responses? Now I can give you another example also. If imagine if this is minus 5y cap, then A plus B will be minus 10I cap minus 5j. That's all. So this is how you add vectors. Okay? Okay. Yes. Okay. It's Niru. Okay. Akshay is putting okay. Okay. Too many okays in one go. Next is the resolution of a vector. Okay, so how you can resolve a vector. So we saw how you can represent a vector graphically, how you can represent a vector algebraically. We also saw how you can represent vector as a unit vector. Now we will see how you can define out the resolution of a vector. Okay, so resolution of a vector means you're taking a vector and resolving it into two components, which means you are taking a vector, you are making it into two components. Okay. You take a vector, you make it into two components. So let's say you have a vector. So let's say this arrow is a vector. Let me not draw that here. Let me just put it here. Okay. Let's say this is my vector. Okay. Let's say this is my vector R. Okay. I have a vector R. Now, I already taught you here that if it's along the x direction, it's x cap. If it's along the y direction, it's y cap or j cap. If it's along the z direction, it is k cap. But what if it's random direction? What if it is not in the x direction or the y direction or the z direction? What happens if it is in a random direction? That is when you resolve the vector. Okay, so you can see this R is in a random direction. So you don't know if it's along x cap or y cap or z cap. So what you will do? You will draw horizontal line and a perpendicular line such that they are at an angle, such that these two lines are at an angle 90 degree. Okay, that is what you will do. Is that clear? So what you will do? You will draw a horizontal line and a vertical line, and this is your vector R. Okay, now R is in a random direction and it is at an angle theta with respect to the horizontal line. Okay, it is at an angle theta with respect to the horizontal line. Now, this two, the horizontal and the vertical, they have to be 90 degree. They have to be at 90 degree. Okay, now, this, whatever I'm going to say now is very important. Very important. Whenever you have a vector in a random direction making an angle theta with the horizontal axis, Okay. The horizontal axis will be r cos theta and the vertical axis will be r sin theta. Okay. So what you can remember is, how you can remember that is, the line close to the angle is r cos theta. The line away from the angle is r sin theta. Okay, put that in your head. If you have an angle, the line close to the angle is r cos theta. The line away from the angle is r cos theta. Now r will change, okay. If your vector is a, this will be a cos theta and a sin theta. Okay. If your vector is b, this will be b cos theta and b sin theta. Okay. Put that in your head. Wherever you have the angle, the line close to the angle or the line near the horizontal line is cos theta. The one away from the angle is whatever vector, sin theta. Okay. Is that all in your head? Yes. We will do a simple question to test if you've understood. Okay. Simple question. Simple question to test if you have understood. So let's say this is, okay, let's just say, okay, let's say there is a vector. This is a vector, okay. This is a vector 20 newtons. Find out the horizontal and vertical component, okay. So what I will do, I will draw two lines perpendicular to each other. This is perpendicular. Now, which is my angle? So I will say this is my angle theta, and theta is equal to some degree. Let's say 50 degree. Okay. Theta is equal to 50 degree. Now find out the cos horizontal component and the vertical component. How will you do that? So if this is the angle, then which is the line close to the angle? It is this one. So this will be, the vector is 20 newtons. So this will be 20 cos theta. So cos 50. So this will be 20 sin 50. Okay. Now let's look at another example. So if the vector is like this. So this is a vector. Here how will I write the horizontal and vertical? This is a horizontal. This is the vertical. Okay. And in my question it is given. Okay. In my question it is given that theta is equal to 30 degree and this is theta. So which will be cos theta, which will be sin theta? Quickly tell me. I will give you a second. Quickly, if you're watching this recorded, please pause the video and quickly find out which is horizontal, which is vertical. NS Viresha, I hope I pronounce your name right. Projectile, I will explain. Okay, watch this class. In another 20 minutes, I will start with projectile. Okay? Yeah. Yes, very good. All those who guessed the answer, this is correct. The angle, the line close to the angle, this one is cos theta. So this is cos 30, but here what is the vector? Let's say the vector is 20 newtons. So this will be 20 cos 30 and this will be 20 sin 30. Okay? Do you understand this? So if you have an angle, the line close to the angle is always cos, the line away from the angle is always sin. Okay? Put that in your head. You will need that. We will do that a lot of times. Okay? Now, here we know the direction of r. How will you find out the value, the magnitude? Yes? So, the magnitude, the value of r, the magnitude of r is given by square root of r along x square plus r along y square. So, rx square and ry square are basically the horizontal and the vertical component. So, r is equal to square root of, what is on the x-axis? R square cos square theta plus what is on the y-axis? R sin theta. So, r square sin square theta. Okay. So, this is how you get the magnitude of r. So, if the question is find out the value of r, what you should do? You should take the x-axis component and the y-axis component, square it and take the square root. Okay. So, this is how you find out the magnitude of a vector r. Now you also know how you determine which one is cos theta, which one is sin theta. The one near the angle is always cos theta. Okay? If this is clear, I want some fire emojis in the chat. Please. Come on, students. Put some fire emojis in the chat. Is this clear to all of you? If it's not clear, I would also love to hear not clear so I can explain it once again. Yeah? Because these are all very important things. You will, if you're someone who's planning to write KCET, NEET or JEE, this concept is very, very important. You have a lot of questions based on this. Okay? Hi, Bharati. Okay, Rekha's put fire. Now, let's look at a question. Okay, so let's look at a question. What is modulus of A? Modulus of A is A. It is just magnitude of A. Okay. Modulus of A means magnitude of A, which is just A. Is that clear? Clear? Hi Netra, welcome back. Yes, Rekha, is that clear, dear? Can you just let me know if it's clear? Yes. Shall we quickly do a question where we apply this? Yes. Shall we quickly do a question where we apply this? Yes, Rekha, in resolution of vector, what is your doubt? In resolution of vector, what is your doubt? You're asking me what the modulus is. So in resolution of vector, the value, the magnitude of the vector is given by r square cos square theta plus r square sin square theta. Okay? NEET chemistry class, you can, for all the class timings, what you should do is you should go to Vedantu Karnataka YouTube channel. There are so many options, right? Like shorts, videos, and then there's an option live. So click on live. So all the classes will be scheduled and you will see the time as well. Okay? Okay? So let's look at a simple question. So there is an inclined plane. Okay. So there is an inclined plane and the plane is at an angle 30 degrees. Okay. So this was the plane and I lift it. So there is an angle 30 degree. Now I keep a block. So this yellow color, what you see, that is a block. So I keep that on the, on the plane. Let's say this is a slide. Okay. So this block, it has its mass and gravity acting downwards, isn't it? It has its mass and gravity acting downwards. Okay? Yes. So this is basically mass times gravity. This is also force. So the block exerts a force in the downward direction. Yes. Is that clear, all of you? Okay. Now, this one we can resolve into two components, which is the horizontal component and the vertical component. Okay, so this mg I can resolve into the horizontal component and vertical component. You can see those two orange arrows, they are at an angle 90 degree. Okay, the angle between the two orange lines is 90 degree. So now I can consider that as the horizontal component and the vertical component. Now I know theta is equal to 30 degree. Okay, if theta is equal to 30 degree and I take a triangle, okay, so if I take this triangle, if I take a triangle like this, okay, if I take a triangle like this, then this angle is 90 degree, this angle is 90 degree. Yeah, so let me write that here. Okay, so this triangle, this is 30, this is 90. Okay, so how much would this angle be? So this is the line mg. Okay, so this is 30, this is 90. So this will be basically 90 minus 30. Okay. Do you understand that? That will be 90 minus 30. So this will be 90 minus 30. Okay. Now, this whole thing is 90. This whole thing is 90. So if this much is 90 minus 30, then this will be what? This will be 30. This angle will be 30. Do you agree with me? I will draw that a little more neatly. So here, this is mg. Okay, this is mg downwards. This is mg and this is my 30-degree angle. Okay, this is my 30-degree angle. So, yeah, this is the horizontal component. This is the vertical component. Okay. So, let's just put this as theta. Instead of 30, I will just put it as theta. So, if this is theta and this is 90, this is 90 minus theta. So, then this angle is theta. Okay. So, this angle is theta. Do you all agree with me? Yes. Do you all agree with me? So, now I have, let me write that here. So I have, this is the horizontal component. This is the vertical component. This is mg. This was 30 degrees. So now I have this also 30 degrees. Yeah? Did you understand how I got that as 30? I took this as 90. I took this whole thing as 90 minus 30. So then the rest is 30. Okay? Yes. So this is 30. So I will just put it as theta. So this is theta. Okay. This is also theta. That is also theta. So what will this side be? The side that is the side close to the angle is always sine theta. So this line represents mg. So the line close to the angle is always cos theta. So this is mg cos theta. This will be mg sine theta. Okay. Mg cos theta, mg sin theta. Students, this kind of resolving is very important. In KCET, so many questions you will get like this. Okay. Now here, okay, I'll answer all your doubts once I finish this. Okay, I see a lot of doubts. So here, what do I have now? I have mg cos theta and mg sin theta. Okay, this is theta. So this is what I have now. Alright. So this is how you resolve the two vectors. Okay. So if there is a block sitting on an inclined plane, this is how you resolve the two vectors. Okay. Is this clear? Clear? Is this resolution clear to all of you? What are the examples? What are the doubts? Give an example of a scalar multiplied by a vector. N.S. Viresha, I believe that is how I pronounce your name. Yes. Okay, let's take it out. Okay, so Viresha has asked a doubt. Give an example of a scalar multiplied by a vector. So, okay, do you want it in terms of okay. So let's say I can always give it to you in terms of in mathematically, but let's say you're driving a car, okay? You're moving in a direction which is represented by a vector. Okay. Now suppose you increase your speed, you double your speed. What happens? Your speed is basically a scalar. The displacement is basically a vector. So how will you find out? When you multiply the two, you're multiplying a scalar and a vector. Okay. Okay. Yes. So is this resolution part? My God. Sorry, students. My phone is falling down. Stay there. Yeah. Okay. Is this resolution part clear to you? Clear to you? Clear to you? We have to move. We have to go towards, we have to do 2D. Sorry, 3D. Okay. So this was all for two-dimensional objects that we saw. If you have x-axis and y-axis. Now for a three-dimensional object, what will you do? For a three-dimensional object, imagine you have a vector. Okay. Let's say this is your vector r. Okay. So this is your vector r. How will I find out the x-axis components, y-axis components and z-axis components? Here I need to consider all three axes. Why? Because this is a three-dimensional object. So it's not just x-axis or y-axis, it's all three axes. So let's say, so this is like a box and r is like this, okay? So I don't have a box with me, but r is like this, okay? So with the x-axis, if this is the x-axis, r makes an angle theta x, okay? So let's say Rx is equal to R cos theta or R sin theta. Yes, the line very close to the angle is always cos theta. So this is R cos theta x. So from this you can get cos theta x is equal to Rx by R. Okay? Cos theta x is equal to Rx by R. Now, we will consider with respect to the y-axis. Okay. So, with respect to y-axis, so let's see how, let's look at the angle that R makes with the y-axis. So, you can see R makes an angle theta y with the y-axis. So, let's put R here. Okay. So, R makes an angle theta y with the which axis? Y-axis. So now you have Ry is equal to, again, is it cos theta or sin theta? The angle close to the line is always cos theta. So this is R cos theta y. So from this you can write cos theta y is equal to Ry by R. Okay. Now let's consider the z-axis. This is the z-axis. Okay. So the angle this arrow makes with the z-axis is called theta y. It was too thick. Okay. So this angle is called theta y. Sorry, theta z. The angle the resultant makes with the z-axis is called theta z. Okay. Theta z. So Rz is what? Rz is R cos theta z. Now cos theta z is equal to Rz by. Okay. Swalpa Kannada Haley. I'm not very good at Kannada, dear. We have two other teachers. Okay. We have Shambhavi Ma'am and Supreet sir to help you with Kannada. Okay. Really sorry. Okay. I'm not that fluent in Kannada. But I will talk in slow English. So you can try to understand. Okay. Is this clear to all of you? So you have R is a vector. So theta x is the angle the vector makes with the x-axis. Theta y is the vector, the angle R makes with the y-axis. Theta z is the angle R makes with the z-axis. Okay. So from that you have Rx, Ry, Rz. You also have theta cos theta x, cos theta y, cos theta z. Now, why am I taking all cos? Because all angles are close to the line. Angle close to the line, cos. Angle away from the line, sin. Okay? Okay? Is it clear? Yes. Okay. Next, vector addition basics. Some basics of vector addition. So first thing, imagine this is a box. This is a car, okay? So this car has a force of 8 Newton backward, okay? It also has a force of 5 Newton and 10 Newton. 5 Newton, yeah, 5 Newton and 10 Newton in the forward direction. What is the resultant force? Quickly tell me what is the resultant force. So resultant force will be what? The resultant force or the net force. Vector quantity, so I should put arrow, will be what all? 10 plus 5 minus 8, which is 7 Newton. In which direction? This is which direction? X cap. Or you can say 7 Newton I cap. This is basic common sense, no students. If two vectors are in the same direction, you add them. If there is one vector in the other direction, you subtract them. Let's look at another example. So here, let's say this has 10 Newton backwards, okay? And in the forward direction, there is, let me write it somewhere else. Okay, so let's say this is a box. Okay, so it has 10 meters per second. Okay, the backward speed is 10 meters per second. Forward speed is 2 meters per second and 4 meters per second. Okay, so total backward is what? Total backward is now 10. Forward is 6. So what is the net speed? Net speed will be what? 10 minus 6, which is 4 meters per second. Okay. Now this is in which direction? Backward direction. So minus. Okay. Minus. It will be minus. No. So this can be written as minus 4 meter per second x cap or I cap. Okay. Is this clear to all of you? Yes? No? Yes, Rekha, it's 4. Very good. Who are you? Rakshita. Can you tell me if it's clear to you? Yes, clear? Yes, 4. Very good, very good. Yes, Bharati, it's Niru. Rakshita, quickly tell me, is it clear to all of you? Yes. Okay. So these are some basics of vector addition. Okay. So if two vectors are in same direction, you add them. Two vectors in opposite direction, subtraction. Basics of vector addition. Okay. Same direction, addition. Opposite direction, subtraction. Okay. Now we will look at the laws of vector addition. Okay. Laws of vector addition. There are two different methods in which you can add vectors. Okay. First one is geometric method. Okay. First one is geometric method. Second one is analytical method. Okay. Two methods in which you add vectors. Geometric method and analytical method. So under geometric method comes the very famous triangle law of vector addition. Okay. Under geometric method, the very famous triangle law of vector addition comes. So if you have two vectors, okay, you have two vectors, you make them like a triangle. You bring them close, you make them like a triangle, and then you find out the resultant. So the resultant will be, if this is A and this is B, the resultant will be A plus B. I will explain it in detail, students. Don't worry. Even if you didn't understand now, I will explain it in detail. Now, analytical method means you don't draw anything. You do the mathematics. So, if R is equal to A plus B. Okay. So, you write R is equal to square root of A square plus B square plus 2AB cos theta. So, this is analytical method. That is, you do mathematics. No drawing, nothing. You only do mathematics. Okay? Now I will explain how you do both of these. Both of these individually I will explain. Yes? Okay. So let's start. First thing, triangle law of vector addition. Okay? Triangle law of vector addition. So for triangle law of vector addition, let's say you have two vectors. Too thick. Let's erase this. Oh my god. Where is my eraser? Yeah, it is here. So let's say you have one vector. This is A. Okay. You have another vector. This is B. Okay. Um, to add them like a triangle, what you should do? You should take A and B and put it like a triangle. So what you should do is, you should take this B, okay, and put it like this. Do you understand? Okay. You should put it like this. Now it formed a triangle. There were two individual vectors. Two vectors, but you put them together. Okay. And then what you should do is, you should make sure, should take this. Okay. One second, let me figure this out. Okay. Yeah. Now I will take, no. Students, please be patient with me. I will take it, okay. Now you should take this A, put it here. Okay. I took that A and I put it here. So I have two vectors A and B. I will put it like this. And then I will draw a line like this. Okay. So this line is basically my resultant. Okay. Okay. Is that clear to all of you? So this line is now my resultant, which is A plus B. Did you understand what I just did? Okay. I will do that once again. Once again. So there is one vector A. Okay. I will use different colors. There is another vector B. Okay. And I need to get A plus B. So what I will do is, I will take B and I'll put it here. Okay. I'll put it here and I'll draw a resultant. And I will draw a resultant. So this resultant is, so this is B. So this resultant is A plus B. Okay. Now what are the rules here? What are the rules here? A, the first vector, the tail of the head of the first vector, which is this, should touch the tail of the second vector. Okay. So if you want to have P plus Q, the head of P should touch the tail of Q. And this will be the resultant. Okay. So when two vectors are aligned, head to tail, their vector sum is the resultant vector. Okay. Yes. Is this clear to all of you? Quickly, let me know in the chat. Pooja IAS, Pujit IAS. Okay, we already have someone who's an IAS in the chat. My God. Is this clear to all of you students? Quickly let me know. Yeah? So this is A, this is B. R is equal to A plus B. Okay? Now, analytical method Okay, is this clear to all of you? Vector addition is clear to all of you? Okay, now let's look at the analytical method. In analytical method, what we will do? We will do mathematics. Not with diagram, with mathematics, we will solve it. So let's say you have P. Okay, let's say you have vector P, another vector Q. Okay, and they are at an angle theta. Okay, P and Q are at an angle theta. Now, what you should do here, students, listen very carefully. It's not tricky, but you should understand. Okay, so P is along x-axis or y-axis, I cap or x cap. So P is along a direction which we know we can find out the value. Q is at a random direction, no. So you can see Q is like this. This is Q. It's at a random direction. So what you should do, you should take horizontal and vertical component for Q. Okay. Now if this is theta, then obviously this will be Q cos theta and this will be Q sin theta. Okay. Now instead of Q, I can write Q cos theta and Q sin theta. Now what will my new vector be? The new vector will be, it will be like this. So this will be Q cos theta. This will be Q sin theta. So instead of Q, I can write this. So now I have Q. But I have P also. Where will I put the P? I will put the P here. Did you understand this? This is the analytical method. So what did I do? First you have green line plus orange line. P plus Q is what you should do. Okay. So this orange line I will make it into horizontal component and vertical component. So now the orange Q can be written as Q sin theta, Q cos theta. And I will add the P as well. P is already on the x-axis, so I will just put it like that. Okay. So now this is Q cos theta plus P. Okay. Now let me find out the resultant. How will I find out the resultant? This is my resultant. And my resultant is basically square root of Q sin theta square plus Q cos theta plus P square. Basically, if this is x and this is y, resultant R will be x square plus y square, Pythagoras theorem. Okay? Is this clear to all of you? So what did I do? Yes, I resolved Q. Since Q is at an angle, I resolved Q into horizontal component and vertical component. Now instead of Q, I will write the horizontal component and vertical component. But vertically there is, horizontally there is P also. So this becomes Q cos theta plus P. Okay? Okay? Now let's do the math. Let's do the math. So let's do the math. So now what do you have? You have R is equal to Q cos theta plus P the whole square plus Q sin theta square root. Okay. So let's solve it. What will this become? This will be square root of Q square cos square theta plus P square plus 2P cos theta plus Q square sin square theta. A plus B the whole square is A square plus B square plus 2AB. That's all that I have done here. Okay. Next what I will do, cos square and sin square I will group. So this will be square root of Q square I will take outside, cos square theta plus sin square theta plus P square plus 2P cos theta. Okay. Cos square theta plus sin square theta is 1. Mathematics. Square root of Q square plus P square plus 2P. Oh my god, here there was a Q. Okay. All those who noticed this, brilliant job. 2P Q cos theta. So this is the resultant. This is the final formula for resultant. So remember here I wrote, see here I wrote vector addition analytical method R is equal to square root of a square plus b square plus 2ab cos theta. Now I have derived how it comes. Now you saw how I got it. Okay? Yes. Okay. Yes, yes. Now you know how I got it. This is the analytical method to get it. Okay? I hope you've understood. Now, if you've not understood, go back. Go back to the video, put it in slow motion, not slow motion, reduce the speed, watch it. I've already spoken very slowly, so you should be able to get it. Okay? Now, this is giving me direction. This is giving me the value. Okay? So, I have the value of R. Now, I need the angle, or I need the angle of R. How do I do that? So, what I will do? Same thing. I will take the same figure, okay? Same figure. So what I will do is I will take the same figure, okay? So let's say this is one, this is the other. Too bad. Yeah. So what was my figure? This was my triangle, isn't it? So this was Q cos theta plus P. This was Q sin theta. Remember? And I had my resultant. Now to find out the angle is what? Angle is here. Okay, so to find out the angle, I will take the resultant on this side. And this is the angle. Okay, now how do I find angle? If that side is Q sin theta, this side is also Q sin theta. Is it? Now, if I take this angle as alpha, so then tan alpha will be opposite side by adjacent side. So Q sin theta divided by Q cos theta plus P. That's all. Easy peasy. Easy peasy. Okay. So once more neatly I will draw this. I don't feel satisfied with my drawing. So what was my vector? I had a vector Q sin theta along this direction and a vector Q cos theta plus P. I took my resultant. So in this case, I will take my resultant like this because I need to find out the direction of theta. So if this much is Q sin theta, then this side is also Q sin theta. And then I just do tan alpha to get this. Okay. So this is the full part of analytical method. Is this clear to all of you? Yes. Quickly let me know in the chats if this is clear to all of you. Let me see if it's visible to all of you. Hi ma'am, how are you? Monster gang, I'm good. How are you? Okay. Is this clear to all of you? Yes. Okay. Okay. Okay, let's move on to the cases where there's minimum and maximum resultant. Okay. So the cases where there is minimum and maximum resultant. So what are the cases where there is minimum and maximum resultant? Okay. So see, students, you got the formulas, right, for analytical method? The formulas are, so this one you have to know, okay. So for analytical method, the formulas are R is equal to square root of P square plus Q square plus 2PQ cos theta. P and Q can be anything, A, B, any alphabet. And tan alpha is equal to Q sin theta divided by Q cos theta plus p. Okay. So this is the value and angle for two vectors. Very important. Okay. Yeah. Now let's look at minimum and maximum resultant. When do we have minimum and maximum resultant? So maximum resultant is when you have two vectors A and B, okay, and they're parallel to each other such that theta is equal to 0. So what will we get? Cos 0 is 1. So the maximum resultant will be square root of A square plus B square plus 2AB cos 0. Okay. 2AB cos 0 is basically 2AB. So this is square root of A square plus B square plus 2AB. Now this is what? This is square root of A plus B the whole square, which is A plus B. Okay. So now we know when is the resultant maximum? When resultant is maximum, R is equal to A plus B. Okay. Now, when do we have minimum resultant? Minimum resultant is when you have theta is equal to 180 degree. What does that mean? That means you have A and B same magnitude but in opposite directions. So let's calculate. So R will be equal to square root of A square plus B square plus 2AB cos 180 degree. Okay. Cos 180 is what? It is minus 1. So this is square root of A square plus B square minus 2AB. So this is equal to square root of A minus B the whole square. So when is the resultant minimum? The resultant is minimum when R is minimum when R is equal to A minus B. Okay. So R is maximum when R is A plus B. R is minimum when R is A minus B. Now you don't have to look at the direction, only magnitude. Okay. Is this clear? Clear? Okay. So these are the conditions for minimum and maximum resultants. Okay. Yes. So we saw the value of resultant. We saw the angle of resultant. Now we saw when it is minimum and when it is maximum. Okay. Now let's look at a question. Okay. Let's look at a simple question. Do we have the time? Okay. So if you have, let's say A is equal to 3 newtons and B is equal to 4 newtons and theta is equal to 60 degree. Find out R. Okay. When it is A plus B. Okay. Find out R is equal to A plus B. So obviously what is the case here? You have A and B at an angle 60 degree. Okay. So what is R? Square root of 3 square plus 4 square plus 2 into 3 into 4 into cos 60. Okay. Now to do the math and solve, I will leave it to you. You can comment the answer in the chat. Sorry, not in the chat, in the comment section. Solve it and tell me the answer in the comment section. I will reply to each of your comments. Okay. So I want you to all put the answer in the chat. Now, if the question was R is equal to A minus B. Okay. If the question was find out R is equal to A minus B, then what you should do? 3 square plus 4 square minus 2 into 3 into 4 cos 60. So that also you can mention it in the comment box. Okay. Okay. Now this is also a question from your NCERT textbook. So the question says, if rain, okay, so rain is falling vertically with a speed of 35. So rain is falling down with a speed of 35 meters per second. Wind starts blowing after some time with a speed of 12 meters per second in the east to west. So this is east, this is west. So east to west is this 12 meters per second. So this is the speed, okay, in which the wind is blowing. The rain is coming down with a speed of 35 meters per second. In which direction should a boy waiting at a bus stand hold his umbrella? Okay. So the rain, what is the resultant here? This is the resultant. Okay. And let's say this is alpha. So what you should do, you should find out the angle at which he should hold the umbrella. So tan alpha is what? Tan alpha is opposite by adjacent. So that is 12. This is also 12. So 35, no, 12 by 35. So this will be, I don't have a Clark's table now. So you can do it with your Clark's table. So this will be 12 by 35. So alpha would be tan inverse of 12 by 35. You will get the value using your Clark's table. So whatever that angle is, that is the angle at which you should hold the umbrella. So if wind is coming this way, I should hold my umbrella like this. Okay. So I think it will be something around 19-20 degrees. Okay. You should find out. That also you can comment. Okay. Yes. Okay. Now we are going to start with motion in 2 dimensions. So it is here where we will look at, projectile motion and uniform circular motion. So motion in 2 dimension means what? The movement that is happening, it involves 2 dimensions. Okay. So if I'm walking along the x-axis only. But if I'm throwing a ball, okay, if I'm throwing a ball, I am throwing the ball, so the ball is moving like this. So it's moving in the forward direction, which is along the x-axis. It is also moving up. So it's moving in the x-axis and the y-axis. Same thing for javelin throw. How does a javelin go? Like this. Like this, no? So it's moving forward, x-axis. It's also moving up and down, y-axis. So if something moves in 2 dimensions, that's called motion in 2D. Okay. Yeah, I should have put some pictures. I'm sorry, but yeah, that is motion in 2D. If something moves in 2 axes. So, you're Ronaldo. Imagine, are you all Messi fans or Ronaldo fans? Huh? So, if Ronaldo is hitting his football, so how does the football go? Imagine, okay, he hits the football. So, the ball goes like this. So, the ball is going in the x-axis and the y-axis. It's moving up and down. So, if something is moving in the x-axis and the y-axis, that kind of motion is called motion in 2 dimension. Yes. Yes. Okay. So in motion in 2 dimension, there are certain things that you need to know. First thing, it is a combination of 1 dimension motions. Okay. So it's a combination of motion in 1 dimension x-axis and another 1 dimension which is y-axis. Okay. So it is basically a mixture because of 2 axes, the x-axis and the y-axis. Okay. At the same time. Okay. This is at the same time. So if something is moving in the x-axis and the y-axis, both the movements are at the same time. Okay. Yes. So let's look at a question. The position of a particle is given by, let's say it's given by r is equal to 3t I cap plus 2, let's say t square, okay, j cap plus 5k cap. This is my question. So now I have movement along 3 axes, x-axis, y-axis and z-axis. Find vt and at of the particle. So I have to find out the velocity and acceleration. So what I have is the distance. Okay, distance is 3t I cap plus 2t square j cap plus 5k cap. Okay. So what is my velocity? Velocity is basically dr by dt, differential of distance. So this is, what is the differential of 3t? 3 I cap plus 2t square is 4t j cap plus 5, the differential of a constant is 0, so 0 k cap. Now how do I find acceleration? Acceleration is the differential of velocity. So what is the differential of 3? 0 plus 4t will be 4. So this will be 4 j cap. Okay. So now I have my quantities. I have velocity is equal to 3I cap plus 4tj cap. So I found out Vt, I found out At. Now one more part of the question, what does it say? Find out the magnitude and direction of Vt at t is equal to 1 second. So at t is equal to 1 second, how do I do that? So at t is equal to 1 second. So I will put t as 1. So this will be 3I cap plus 4j cap meters per second. So along the x-axis it moves with 3. Along the y-axis it moves with 4. Now if there was a question to find angle, what will you do? You will find out the angle also. So along the x-axis it moves with 3. Along the y-axis it moves with 4. So the angle will be tan alpha, which is tan of opposite by adjacent 4 by 3. Okay? Yes. Is that clear, all of you? Clear? Yeah. Superb. Now with this, we are going to start with the very famous, the most important projectile motion. Okay? So this is like one thing that is very confusing to all of you, but it's very important. Okay? So are you all ready to learn projectile motion? All those who are ready to learn projectile motion, put some fire emojis in the chat. Quickly. Let the chat be full of fire emojis. Projectile motion. What is projectile motion? As I said, see when someone kicks a football, it's the motion it takes. If you throw a ball, the motion it takes. When you take a sprinkler and sprinkle water, the motion it takes. All that comes under projectile motion. Okay, so projectile motion is, our Neeraj Chopra, he threw his javelin using what motion? Projectile motion. Yes, we're all very proud of that, right? So there is a lot of physics also. So if you actually look into everything around you, there's physics everywhere. So that is the physics behind that javelin throw was projectile motion. Now I'll tell you at what angle he should have thrown for the javelin to go maximum. Okay, with physics we will tell him that. Okay, he would already know, but then we will also know now. So what is projectile motion? So projectile motion is when, so somebody had asked me this doubt, what is projectile motion? So projectile motion is when any body that is thrown, okay, with some initial velocity, it moves under the influence of gravity alone. Okay, if I was standing, I could have shown you, So this is a javelin and I throw this javelin. The javelin moves because I push it. But after some time, it moves by itself. There is no motor on the javelin. So it only moves because initially I push it, and then the rest of the motion is only because of gravity. Do you all agree? Yes? So if you have a javelin, you push it, you throw it initially. Initially it moves and then it continues its motion only because of gravity. Okay, so that is what is written here. Any body which once thrown into space with some initial velocity moves thereafter under the influence of gravity alone without being propelled by any engine or fuel. What is the meaning of that? First you throw it and then it continues to move only because of gravity, but there is no motor or anything. Okay? Okay? So this is called projectile motion, and the path the projectile takes, that kind of a path is called parabolic path. Okay? What is the path called? It's called parabolic path. All of you agree? If I have a ball, I throw the ball initially moves because of the force that I apply, but then it continues to move only because of gravity. So it moves along a projectile path. It's called a parabolic path. Okay? Are you all sleeping in class or are you all still awake? If I could see all of you, I would have cracked some jokes, but okay, projectile motion, the idea is clear? Yes. See, if you want, you can watch the recorded version with a speed of 2 into 2 or into 1.5 and all that. But I am talking slowly because these are all very important concepts. Okay? Yes? Okay. Now, certain things that you need to know about projectile. What are the certain things? First thing, you start from here. You start from here. Okay? You start from here. Initially, you go with a velocity of u. Okay? Initial velocity is u. So this u, so this is like this. This is u. U is in a random direction. So you can resolve it into horizontal and vertical. See, now you know where to apply what we just learned. So the horizontal component is what? The line close to the angle is always cos. So this will be, it's along x-axis. So ux cos theta. Vertical component is along y-axis. So uy sine theta. Yes, you should be an expert in this part now. Theta, so close to theta is cos theta. It's along x-axis, so ux. Far away from theta is sine theta. It's along y-axis, so uy. So the initial velocity u is given as ux theta and uy theta. Okay, that is one thing you need to know. Now, the height of the projectile. Okay, the height, which is the height, this one. This is a maximum height. So this maximum height is very small compared to the radius of the earth. See, if I throw a javelin, it can go to a maximum height. It cannot go after that. It cannot go up till space. Can it go? See, if I was Wonder Woman or if I was Superwoman or Superman or something, I can. But if a normal man, even if Neeraj Chopra throws it, it will only go to a certain height. It has a maximum height. It will not go up to space. So the certain height up to which whatever you throw goes is very small compared to the radius of the earth. Okay? It's very small compared to the radius of the earth. That is the first point. Radius of, say, if this is the earth. If this is the earth, the radius is very big. You are only throwing it here. Very small angle. Okay? So, the height at which you throw your projectile or you throw your object is very small compared to the radius of the earth. Okay? And even the distance you throw. What is range? Range is the maximum distance you throw till point C. So that range is also very small compared to the radius of the earth. Okay? Okay? Now, the earth's surface is assumed to be flat over the range of the projectile. What does that mean? So, if I am throwing my javelin from here and it goes all the way till here, assume that the earth is flat there so that the base is straight. Okay, that's all. If I'm going to throw from here to here, I'm just assuming that the base is flat. Okay, if the earth is curved and all, then it's going to be complicated. So you're going to assume that earth is flat over the range, over where you throw the projectile. Okay, so these are things you know. Air resistance is also ignored. No air resistance. Okay. Next thing that you should know here is, every time you want to find out the direction of velocity, you should draw a tangent at that point. So for example, here initial velocity is like this. Here 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 like this. So any point on the parabola, if you want to find out the initial velocity, you have to, no, if you want to find out the direction of velocity, you have to draw a tangent. So all these red arrows give you the velocity at all those points. Okay? Raj Gowda, I have a doubt. What is your doubt, Raj Gowda? You can ask me. Hello Danraj, welcome to the class. What is your doubt, Raj Gowda? Is this clear to all of you? So to get the direction of velocity, what should you draw? You should draw a tangent at the curve at that particular point. Okay. So now if I want to find out the direction of velocity at this point. Okay. What do? I draw a tangent. That's all. Okay. Yes. Okay. Now, what else? This is the maximum height. This is the maximum height. I will put it as h max. That is the maximum height of my parabola. Okay. Now you can see here and all. Here. So here you can see velocity has a y-axis component and an x-axis component. Isn't it? Velocity is at an angle. But at point A, you can see velocity is along the x-axis only. There is no y-axis component. Did you understand? See, at every other point, velocity is at a random direction. But at point A, see, velocity is along the x-axis. isn't it? So this is the velocity component. It's along the x-axis. So at point A, at maximum height, you can say that, here you can say that velocity along y is equal to 0 because velocity is only in x-axis or x direction. But any other point you take, you have two components. See here, velocity is in a random direction. So you need to take y-axis and x-axis. But only at point A, velocity is along x-axis only. Okay? Yes. So this is H max. Okay. Raj Gowda has a doubt. Ma'am, vectors resultant can be by adding two vectors directly or only by formula. So Raj Gowda, if you have two vectors, okay, if they are at an angle, then to find out the resultant, you have to do r is equal to square root of a square plus b square plus 2ab cos theta. But imagine if you have two vectors, okay, I mean, whenever you add vectors, you can use that formula. But if you have two vectors that are parallel, you know that the angle is 0, so you can directly add them. Okay. If you have two opposite vectors, you know that the direction, velocity, I mean the angle is 180, so you can just subtract them. But in general, you have to use the formula. Okay. If there is an angle, if there is no angle, you can just add or subtract. Like this example where I have done it. Let me show you. See here. So here there is no angle. One is forward, one is backward. So here I have just added them or subtracted them. But if the vectors are at an angle, you need to use the formula. Is that clear, Raj Gowda? Yes? I hope it's clear to you. Okay? Is it clear, Raj Gowda? Okay, so in this picture, what all did you learn? Now you learned that initial velocity is along y-axis and x-axis. Along x-axis, it is ux cos theta is along x-axis. Along y-axis, it is uy sin theta. The maximum height is at h max and maximum height is at h max, and at the maximum height at point A, there is no velocity component along y-axis. It is only along x-axis. Wherever, whichever other point you take, there is velocity along x-axis and y-axis. Only at maximum height, there is no velocity along y-axis. Velocity is only along x-axis. This much you learned now. Okay? Okay. Okay. Sumit Kumar, ma'am, I like your teaching, ma'am. Thank you, Catherine, ma'am. I'm very happy to hear that, Sumit. Okay, thank you so much. So please share this to all your friends. Tell them there is a teacher you like and let them also learn. Okay. Raj Gowda, I will do friction probably on Saturday. Okay, most probably Saturday I will do friction. The Saturday timing, you can always go to Vedantu Karnataka live section. Check on Friday. On Friday, it will be scheduled. Okay. Okay. I've already done unit 1, units and measurements I have done. Motion in a straight line also I have done. This is motion in a plane. Please do watch those videos as well. Friction I will do on Saturday. Okay, coming back to projectile motion. Are all these points clear to you? Okay, if all these points are clear, so what are the components of initial velocity? So the components of initial velocity, what are the different components? Along x-axis, it is u cos theta. Along y-axis, it is u sin theta. Okay. Now, Sumit Kumar, I already said your name. Okay, I told you. Sumit Kumar likes Catherine ma'am. Okay. And he wants me to call out his name. Thank you, Sumit Kumar. Okay. So u so cos theta, u sin theta. Now you can see here along the center, if you see, both the sides are the same. The amount of time for the ball to reach A and from A till C, it takes the same time. So here, the time in which the ball goes up and the time in which the ball comes down is the same. Time of ascent is equal to time of descent. Okay? Okay? Okay. So since all of this is clear, we can move on. We can move on. I studied second PUC from you, ma'am, and I scored 98. Wow. Congratulations, Sumit Kumar. That's great. So, what should you do next? You should tell all your juniors to also study from Vedantu, Karnataka and study from Yatran ma'am. Okay? Yes? Did you tell your juniors that? Yeah? Okay. So, what else do we have to see? Now, I think that's all. Then let's just start. So, let's look at the different things. So, here I can also tell you one more thing. One more important thing I'll tell you. So here, this is u cos theta only. But if you take this point, okay, here you'll have u cos theta and u sin theta. Any other point you take for velocity, you will have u cos theta and u sin theta. Only at point A, it will be u cos theta alone. Okay. So along x-axis and y-axis, let us break down what are the different motions that are taking place. Okay. So let's write it down. So first thing, along x-axis, ux is what? U cos theta. Okay. Now vx, which is the final velocity, will be the same as the initial velocity. So this will be u cos theta. Okay. What about the acceleration? Along the x-axis, is the ball accelerating? So if I throw a ball like this, it's going up and it's coming down. Now it's going up because of the force that I threw it. It's coming down because of gravity. It is not moving in the x-axis. It is not accelerating along the x-axis. It is accelerating up in the y-axis. It's accelerating down in the y-axis. So along x-axis, acceleration is 0. And the motion is also called as uniform motion. So I hope you understand this. Okay. Now along y-axis, what is happening? Initially it goes up and then it comes down. Okay. So when it goes up, it has a velocity of u sin theta. When it reaches the topmost position here it is y is 0. There is no velocity at the topmost point, and then it comes down. Okay. So here acceleration is because of what? Acceleration is because of gravity. Acceleration is because of gravity, and uy is u sin theta. Okay. Uy is u sin theta. These are some important terms that you need to know. Uy is u sin theta. And here there is motion under gravity. Okay. So these are the different things happening along x-axis and along y-axis in a projectile. Now we will find out, we'll derive range, if it is a parabola, all of those. Time of flight, all of that. Okay. Okay. What is this? Raj Gowda, ma'am, can you explain law of sine and law of cosine when it is used to find direction of vector? Raj Gowda, did you watch the video from the beginning? So in the beginning of the class, I have already done that. Okay. You can just watch this after the live class. You can watch the starting part. I have already explained that. Okay. Yes. Okay. Let's move on. So, yeah. So this is basically explaining the symmetry. Okay. So it tells you how projectile motion is there. All this we've already discussed. So you can just, go through what is this. So maximum height is at the center, halfway through. And the angle at which it is launched is the same as the angle at which it lands. The time taken to go up, time taken to come down, both are same. Okay, and it starts from the same plane, it ends on the same plane. Same things we discussed. Next is very important, time of flight. Okay, so we are going to derive from here onwards. You might get questions. So in your PU exam or your FA1, they might ask you derive time of flight project for a projectile motion. So what will you do for that? So first thing you should do is, initially what happens? So first thing you should know, the total time of flight is the total time taken to go up plus the total time taken to come down. Okay, so from here you throw, it comes up, comes down. So total time taken is the time taken to go up and the time taken to come down. Now in which direction is this moving? This is moving along the y-axis. First it moves up in the y-axis, then it moves down in the y-axis. So you should take it along y-axis. Okay, so let's write down the equation of motion. Why do I write down the equation of motion? Because here something is moving. So something is moving along the y-axis. So I should write it along the equation of motion. So the equation of motion is v is equal to u plus at. Now if I'm throwing something in a projectile motion, when it lands, when it reaches the ground, what is its final velocity? 0. So final velocity is 0. 0 is equal to initial velocity along y-axis is uy plus what is the initial acceleration? It is accelerating in the upward direction against gravity. So this is minus gravity into TA. Why it is coming up? So TA. Okay, TA. So now what is this? U of y minus g t ascending is equal to 0. So u of y is equal to g into t ascending. So now you have t ascending is equal to u of y by g. Now t ascending is the same as t descending because it's the same. So now can't I write t is equal to 2 into, okay, let's not write that. Let's write t is equal to uy by g plus uy by g. Okay, ascending and descending, they're both same. So uy by g plus uy by g, which is 2uy by g, which is 2 into what is uy? U sine theta by g. So now I get the formula time of flight. Okay, time of flight t is equal to 2u sine theta by g. This is the formula. Is this clear to all of you? Yes. So what all did I do? First thing I proved that, I stated that the total time taken is the time taken to go up and the time taken to come down. And this motion, this whole thing is along y-axis. So I will apply equation of motion along y-axis. So what is the first equation of motion? V is equal to u plus at. What is the final velocity when a projectile reaches the ground? The final velocity is 0. So 0 is equal to initial velocity along y-axis is uy. Acceleration is in the upward direction, so minus gravity, and the time taken will be ta. Okay, this is time of flight. Next is maximum height, h max. So let's do maximum height. So what is the maximum height? Maximum height is the maximum height the projectile can take, which is this. So I have to find out what is the maximum height. Okay, so again, this is also along y-axis. So y-axis and applying along the y-axis, applying equations of motion. Okay, along the y-axis, applying equation of motion. So which equation of motion I'll apply here? Here what I will apply is v square is equal to u square minus 2as. Okay, so here also final velocity is 0. Initial velocity is uy square minus 2 into acceleration is because of gravity minus g, and s is the distance. Here what is the distance? The maximum height, which is h max. So let me take it to the other side. So this becomes uy square is equal to minus uy square is equal to minus minus becomes plus. So this becomes 2gh max. Okay. So from this, what is h max? H max is equal to minus. Okay, this is 0, right? So this will go to the other side. Minus. Wait. One small correction. The formula is v square minus u square is equal to 2as. Yeah, now it's correct. So 0 square minus u square is equal to, so this is plus. Okay, so now h max is equal to uy square divided by 2g. So what is uy? U sine theta. So uy square is u square sine square theta divided by 2g. So that's all. So the formula here is h max is equal to u square sine square theta by 2g. Simple. Isn't it simple? So here, the only things that for every question you need to draw diagram, okay? So here this is u, so u sine theta, and here vy is equal to 0, okay? Y axis, at maximum height vy is equal to 0. Okay, so here v is 0 because at maximum height vy is 0, okay? Forgot to mention that. Is this clear? Okay. Next is the horizontal range. So what is horizontal range? The maximum point it can go. So C, from O to C, this is the range. So the maximum distance it can go is the maximum range. Okay. So now, is this along y-axis or x-axis? That is my question to all of you. So this horizontal range is the motion along y-axis or x-axis. Obviously, it is along y-x-axis. Okay, so the range is along x-axis. Alright. So range is along x-axis. So let's do it. Let's do it in violet. Okay. So this is along x-axis. Okay. So first thing, let's find out the speed. So the speed along x-axis is what? Distance divided by time. Okay. So from this, distance is speed into time. Okay. Now distance is what? Distance is range. Okay. So distance is range. So range is the initial velocity, which is ux, into time is t. So then range is ux. How much was ux into time? Time we already discussed. What is t? T is how much? T is 2uy by g. Okay, so I will put that here. So this is 2uy by g. Alright, 2uy by g. Now let's solve it. So range is equal to 2ux uy by g. So that is equal to 2 into u sine theta, u cos theta, the whole divided by g, which is equal to u square, I will take that outside, into 2, what remains? U square into 2. Okay, mathematical, I can make this an identity. I can say this is the same as u square, I take it outside. So 2 sine theta cos theta, I can write it as 2 sine theta minus cos theta by g. Can I write it like that? Identity? Yes. So this I can also write it as r is equal to u square sine 2 theta by g. Yes. So this is my final formula. R is equal to u square sine 2 theta by g. Okay. Now, when is R maximum? R is maximum when theta is how much? That's very important, students. So, sine 90 is when it is maximum. So, here it is sine 2 theta. So, for 2 theta, how much should theta be? 45 degree. Okay, only then 2 into 45 you will get 90. Okay, so maximum angle is, so sine is maximum when sine is 90. Okay, so sine 2 theta should be 90. So theta should be 45 degree. So if Neeraj Chopra throws his javelin at 45 degree, it will go longest. Okay, so 45 degree is the angle at which the range is maximum. Do you understand that? Yes. Okay. So this angle theta should be 45 degree for maximum range. Okay. So let's erase this part. Any doubts here, students? Any doubts here? Okay. So this is maximum. This is the derivation for horizontal range. Next is complementary angles. You might not have learned about this. It's a very, very simple concept. You might have learned about this. Yeah. Complementary angles is when you have two projectiles. Okay. Let's say this one and this one. They have the same range. That means along the x-axis, they travel the same distance. They have the same range. Okay. So you can see here, the range of a 15 degree is the same as the range of a 75 degree. Okay. So this takes place only if it obeys the condition theta 1 plus theta 2 should be 90 degree. So here you can see what is 15 plus 75. 15 plus 75 is 90 degree. So this is possible. Okay. Now here I can give you another example. This is 30 and this is 60. Okay. So R of 30 is equal to R of 60. Here also theta 1 plus theta 2 is 90. So complementary angles is when you have two projectiles, they have the same horizontal range. Okay. Then they are complementary angles. And the criteria for complementary angles is theta 1 plus theta 2 should be equal to 90 degree. That's all. Simple concept. Okay. Yes. Okay. Next is the equation of a trajectory, or a relationship between x and y, or the question could be show that the path of your projectile is a parabola. Okay. To show that path of your projectile is a parabola. Okay, before that, students, here I can prove, complementary angles using a simple derivation. Okay, so it's very easy. So we know that the formula for range is what? U square sine 2 theta by g. Yes, we just derived that. U square sine 2 theta by g is the formula for complementary angles. So for R1, it's theta 1. So for R2, this is U square sine 2 theta 2 by g. Okay. U square sine 2 theta 1 by g, U square sine 2 theta 2 by g. Now we already know that theta 1 plus theta 2 should be equal to 90 degree. So theta 2 should be 90 minus theta 1. So here I will substitute that. So this is U square sine 2 into 90 minus theta 1 by g. Okay. Now R2 is equal to U square sine 90 minus theta 1 can be written as 180 minus 2 theta 1, mathematical identity. So this is sine 180 minus 2 theta 1 by g. So this is basically U square sine 2 theta 1 by g. So R2 is the same as R1. So this is a proof for complementary angles. So you prove that R2 and R1 has the same formula. Okay? Very easy concept. Complementary angles is very easy. Okay? Okay. Now, let's look at the equation of trajectory or show that the path of something is a parabola. Okay, the path of a projectile is a parabola. How do I show that? To show that, first I will write down the relationship. So this is a formula figure. Now I think it's thorough to you. So at this point, this is the velocity. It has x component, y component. Here, this is the velocity. It has x component, y component. Here, velocity has only x component. Here also, velocity has x component, y component. Here also, velocity has x component, y component. Okay. Only at the center, velocity has only y component. Okay, so we're going to show that path of a parabola is a projectile. Okay, let's do that. So first thing, we need to write down along x-axis and y-axis what all happens. Okay, so along x-axis what happens? Along x-axis, the path is ux into t. Distance is speed into time. Time is time is x by ux. Time is x by ux. Okay. Now along y-axis what happens? Along y-axis it is actually moving. So you need to use the equation of motion along y-axis. Okay. So along y-axis you need to use the equation of motion. So s is equal to ut plus half at square. So from this you will get instead of ut, so this is basically going to be s is basically y is equal to uyt plus, not plus, minus, the acceleration is minus g. So this will become minus half gt square. Okay. Now what I will do is I will replace t with this. So with this formula, I will replace t here and here. Okay. Now what do I get? I will get y is equal to. Okay. So I will get y is equal to uy x by ux minus half g into x by ux the whole square. Okay. I just replace t with x by ux. Is that much clear? Minus half. Okay. Now let's just do the math. Now what I will do? I will just solve it. Simple steps. So I will write down that formula here once again. So what is the formula? Y is equal to uy x by ux minus half g x square divided by ux square. Okay. Same thing, I just wrote it down here. Okay. Now let's do the math. This is equal to, what is uy? We know that it is u sine theta. So u sine theta into x. What is ux? U cos theta minus half into g into x square. Again ux square is u square cos square theta. So here you can see there is a y here, there is an x here, there is an x square here. Okay, so isn't this of the form y is equal to ax minus bx square, which is the equation of a parabola. Okay, so this is the equation of a parabola. So what is a? A is equal to u sine theta by u cos theta, and b is equal to half g u square cos square theta. Do you understand this much? Okay. Yes. Okay, is this clear? Yes. Is this clear, all of you? Okay. So this is how you can show that it is equal to a parabola. Okay. Hello, Sanjay. I'm really doing well. How are you? Listening to my class after a long time. Hello, Sanjay. Sanjay finished yeah, second PUC, right? Okay. Is this clear to all of you? Okay. Clear, ma'am. Okay. Luna said it's clear. Very good, Luna. Now, this is not the end. There is a little more portion to this. So, now what we can do here is we can continue this. Okay. So, now we know that y is equal to x tan theta. Okay. Sin theta by cos theta, I can write it as tan theta. Okay. That also I should write here. So, a is equal to u and u will cancel. Okay. So, this is basically tan theta. Okay, students, here I forgot to write that. I mean, it's not that I forgot. I can write it in the next step also, but this whole thing, this whole thing, I can write it as tan theta. Okay. So now what is my formula? X is equal to, y is equal to x tan theta minus half g x square divided by u square cos square theta. Okay. Okay. So now what I will write? I can write this as y is equal to x tan theta minus x square, okay, x square, the whole divided by 2u square cos theta into cos theta. So cos square theta, I will write cos theta into cos theta, and I'll take g and divide it in the denominator. Even if I put g in the numerator or here, it's the same thing, right? Yes. Yes. So I take g and I divide it here. So this g, I will take it to the denominator. Okay. Now what I will do, I will multiply it with sine theta. Okay. So here also I will put sine theta. Here also I will put sine theta. Okay. So I'll multiply and divide by sine theta. So now what do I have? Y is equal to x tan theta minus x square. Sine theta is here. 2 u cos theta, u sin theta, cos theta, the whole by g. Okay. So now this I can write it as y is equal to x tan theta minus x square. Both of these together will become tan theta. Okay. Divided by, what is 2u cos theta, u sin theta by g? It is r. Okay. So now I will get y is equal to x tan theta. I'll take x tan theta outside. So 1 minus x by r. So these are the two formulas. Okay. So these are the two formulas to show the relationship. Okay. Okay. Is this clear to all of you? Okay. So this is clear. So this is the equation of trajectory relationship between x and y. Okay. If you have any doubts, you can just go back and watch it once again. Okay. So don't just watch this like you're watching a movie. Okay. Take a pen, paper. Along with me, you write down the steps. Then you will be easily able to do this. Okay. So along with me, you write down all the steps. Then easily you will be able to do this. Okay. Now last topic of the day, which is circular motion. Yeah. What is circular motion? So if I have this and I'm rotating it like this. Okay. Let's say I have a wire. I don't have a wire that I can rotate now. Okay, if I have a wire and I just rotate it like this, that is circular motion. So I have a point and it's rotating like this, like your fan. Anything that rotates like that is circular motion. Okay. Your fan, this child rotating it. Anything that rotates along a particular axis is called circular motion. Okay. Now here you can see anything that moves in a circle is a circular motion with a reference point. So here this could be the reference point and then this could be the radius. So it's moving in a circular path. Okay. Now circular motion is divided into two: circular kinematics and circular dynamics. Circular dynamics we will learn when you learn laws of motion. Okay. In this chapter, we are going to look at circular kinematics. So we don't have to look at how something is moving. We look at how, what describes its motion. Okay. So in kinematics, there are two terms that you need to know: uniform circular motion and non-uniform circular motion. So what is uniform circular motion? It is the motion of a body along a circular path. Non-uniform circular motion, it is the motion by changing speed. So if I just rotate this like this, it's moving with the same speed. So it has uniform circular motion. So in uniform circular motion, it moves with the same speed, but the velocity is not same. So what happens? So what is velocity? As I said, at every point to find the velocity, you draw a tangent. So you can see here the velocity is up, here it's to this side, here it's down, here it's on the opposite side. So at every point, velocity is changing, but the speed is the same throughout. Okay. So in circular motion, one thing you should know is velocity is changing throughout. Speed is a constant. Okay. So that could be a question. Is velocity constant? No, because at every point the velocity changes. The direction will change. Okay. Yes. Now uniform circular motion has what all? It has speed. The speed is a constant. Okay. Velocity is what? Velocity, it changes due to change in direction. Changes due to change in direction. And time, what is time period? Time period is the time taken for it to complete one full revolution. Okay. So time period is the time taken for one full revolution. Okay. So let's look at some mathematics also. So if v is the speed, okay, if v is the speed, what is speed basically? Speed is distance by time. Okay. Now for a circular path, what is the total distance the object should take? It is from here to here, which is the circumference of a circle. Okay. How much is the circumference of a circle? 2 pi r divided by the time. Let's take it as t. So from this we will get t is equal to 2 pi r by v. You can also say that frequency is equal to 1 by time period. Okay. Yes. Okay, so these are some mathematical terms relating speed and frequency and time for uniform circular motion. These are all very simple topics. Next, you need to know what is centripetal acceleration. Centripetal acceleration is acceleration of a circular moving body. Any body that moves in a circular path will have centripetal acceleration. And centripetal acceleration always points towards the center. So you can see these blue arrows. It's always pointing towards the center. Okay. So centripetal motion acceleration is acceleration towards the center. Okay. And the formula for centripetal acceleration is v squared by r. Okay. So only velocity changes, speed is constant for centripetal acceleration. Not just for centripetal acceleration, for any circular motion. Now let's just quickly derive the formula for centripetal acceleration. So consider, a circular path. So let these two be the radius of the path. Okay. And let's assume that it moves with a velocity v. Okay. So at that particular point, at this particular point, let's say the velocity is v. Okay. Now at this point, the velocity is v this way. It's always, a tangent drawn. So there's v on both the sides. Now if you just extend this, okay, you will get a shape like this. So if this is theta, this is obviously 90 degree, this is 90 degree. But the whole thing, this is like a figure that's fully 360 degree. So if this is theta, 90 and 90, then what should this angle be? Shouldn't this be 180 minus theta? Yes. So this whole thing is 360. The opposite angles are 90. So this is theta. So this angle should be 180 minus theta. If that is 180 minus theta, then shouldn't this be theta? Yeah, straight line, right? So if this much is 180 minus theta, the rest should be theta. Okay. Now let's just draw these triangles separately. Okay. So this is the triangle representing V, theta, and theta. Okay. And V. Okay. Now I have one more triangle with my R's. Okay. So this is R, this is R, this is theta. So now I have two triangles. This I've just drawn from the main figure. I've just taken these two theta angles. Now if I draw a line here and I draw a line here, aren't both these triangles identical triangles? Okay, it's just that they're in different shapes. But both the sides are the same, V and V, R and R, angle is theta. The orange lines are also the same. So these triangles are basically identical triangles. Okay. Now, let's say this side is V plus V. So I put it as delta V. And this side, let's say it's delta R. So now what we have? We have, if two triangles are similar triangles or congruent triangles, we can equate them. So what will we equate them? Delta V divided by delta R is equal to, I will take one of the sides V by R. Okay, I'll just take small letter everywhere. Okay, so let me just take small letter everywhere because in the final formula in your textbook it is small letter. So R, delta R. Okay, yeah. So from the two triangles, I took the two sides. I just equated the two sides. So now what I will do is I will just multiply delta T. Okay. So delta V by delta R. No. So delta V is equal to delta R into V by R. So on both the sides, I divide by delta T. Okay. So what is change in velocity by time? Acceleration. What is change in distance? R is distance. Change in distance by change in time? Velocity into V by R. So from this you get acceleration is equal to V square by R. Okay. So this is the derivation. So the important concept here is okay. So the important concept here is you need to know the figure. So make sure you will understand the figure. Okay. And these two triangles are congruent triangles. Okay. Okay. Now some parameters of motion. This is just, you just need to know the parameters. So there's angular position. So if, something is moving at an angle, that position is called angular position. Now imagine this is the initial path. And then it reaches here and then it reaches here. Okay. Okay. So this is theta and then it becomes theta 1. Let's say this is theta 1 and then it becomes theta 2. Then it goes to theta 3. Then it goes to theta 4. It just rotates. So the displacement, the angular displacement will be theta 2 minus theta 1. Very easy, no? So this is initially it's here. It goes to theta 1, then it goes to theta 2. But how much has it moved? Theta 2 minus theta 1. That is the angular displacement. Now what is angular velocity? Angular velocity is basically omega. Okay. So angular velocity is delta theta by delta t. How did I get that? See, normal velocity is what? Normal average velocity is change in displacement by change in time. So here, angular velocity is what? Change in angular displacement by change in angular time. We learned here angular displacement is delta theta. Okay. So angular velocity is delta theta by delta t, which is angular displacement by angular time. Now, instantaneous velocity can be given as limit delta t tends to 0 del theta by del t. So this can also be written as d theta by dt. Okay. So instantaneous angular velocity is d theta by dt. Linear velocity is del x by del t. Okay. Next, using the right hand rule, you can actually get the direction of angular velocity and angular displacement. So imagine your particle is moving like this. Okay. So what you should do is you should take your right hand. And curl your fingers in the direction in which the motion is. So you can see if I curl it along the arrow, then this thumb is pointing towards you. So that is the direction of omega. So omega is inwards. Now, if it is in the opposite direction, omega is outwards. So, omega is what? Angular velocity. Okay? Yes. Now, what about angular acceleration? Angular acceleration is given by the alphabet alpha. All these are very important, students. Alpha is average acceleration. That will be what? Angular velocity by angular time. So, instantaneous acceleration will be dw by dt. Now, what will the units be here? So, angular velocity unit also I haven't derived, right? Angular velocity unit is theta, which is radian by second. So, angular acceleration will be radian by second. So, this is radian by second square. Okay. So, angular acceleration is radian by second square. So, these are all some parameters of angular motion. Okay. So, we know when something moves in a straight line, it will have velocity, it will have acceleration, it will have displacement. Now, when something moves in an angle, when something takes a circular path, it will have angular displacement, angular velocity and angular acceleration. Okay. So, angular displacement is given by del theta. Angular velocity is given by omega. Angular acceleration is given by alpha. Okay. So, you need to know linear parameters and circular parameters. Okay. Yes. So, that is one shot of motion in a plane. I hope you enjoyed the class. I haven't solved a lot of numericals here. So, if you want numericals, you can comment numericals and I will do a class on that. Okay. If you want numericals based on each of these, I will definitely do all that. Please comment numericals. Okay. I hope you enjoyed the session. Please let me know how the session was. I would be very happy to hear from all of you. Sanjay, Sanju, Catherine ma'am, I took long term for NEET ma'am. Okay, I will teach you physics, Sanju. Don't worry. Okay, I've already done most of the chapters, like the first part for your first unit test. All those chapters are already done. By August or October, we'll finish all the chapters. Okay, don't worry. Don't worry, Sanjay. Yes. We will definitely solve all that. Anything else, students? Shall we wind up the session? Yes. So how was the class? Okay. So these are all some motion parameters. What are motion parameters? Parameters that describe motion in a circular path. Okay. The position is described by theta, displacement delta theta, and then the rest I already explained. So we learned about vectors. We learned about motion in 2 dimension, which is projectile motion and uniform circular motion. Okay. So that's it. I'll see you with another class. Thank you. Thank you all. I love you all. I'll see you in my next class. Please let me know in the comments